All right. Hello, hello. Let's see if we can.
All right, folks, we're gonna get started.
If you can hear us, maybe give us a little thumbs up. We're gonna get started here in a second. We'll just.
All right, everyone. Let's.
Oh, did I kill the? I kill the picture. Okay. Let's see if we can. Brandon, we'll start with you, if that's okay for you.
Yeah, should I start?
Yeah, you want to sit there? Put the puppy on camera.
All right, everyone, please take a seat. We'll have more time.
We'll have more time for networking in a bit. Also, I think I'm not sure I put a disclaimer in there, but like by attending this event, you agree to being live streamed, which is happening just now. That's right. Also, Brandon, I sent you the link to the live stream studio on Twitter. If you could open that on your laptop.
Oh, is there something I need to do for the?
Yeah, it's just a web browser based. So just need to open the.
Do I need to open the Twitter link?
Yes.
Okay. Let me disconnect from this real quick.
Awesome. Thanks, Ron. Ron, maybe let us know if you can hear us. Okay.
I gotta use a non-Safari.
Awesome. Thanks. Okay. Yeah. Wi-Fi password is 1234567 And do you want to clip that on, or just maybe actually clip it on your? You have to share it with maybe there.
Yeah, sure. For the StreamYard, do I need to give it access to my screen sharing or something? Or?
Yeah, I think so.
Okay, I see this. So present.
Yeah, if you click present. Yeah,
Share screen.
While we're setting everything up. Thanks everyone. Everyone always sits in the back. I don't know why. This is actually, I put the couch right there. Quite nice, but I know this looks pretty terrible, but it actually is quite comfy. Surprisingly comfy.
Okay. Screen mirroring.
Please don't open the YouTube. Anyone who's got the YouTube open, please turn off the.
Okay, are you able to see the StreamYard screen sharing? Is that working good?
Yeah.
And the audio is also good? Test 1, 2, 3. Test 1, 2, 3.
Ron says good.
Says good? I'll just start. I mean, I don't have any way to listen to them, so. Hello?
Yeah, maybe let me do a brief intro, actually.
Sure, yeah. Maybe start talking so they can hear you.
Yeah, I have a microphone as well. So yeah, thanks everyone for joining. Maybe I can turn the camera around for a second. Hi there. I'm Thor. You can find me Thor Web Dev on the interwebs. I do open source things at Superbase. I'll be speaking about that in a second. I also organized the Hacker House Taiwan. It's just kind of a passion project of basically bringing remote engineers and locally working engineers together to work from Taiwan. We've done one earlier this year, and yeah, if you're interested in that, just Google Taiwan Hacker House or Hacker House Taiwan, and there is a Google form somewhere where you can submit your interest, and maybe we'll do the next one in Kaohsiung because the weather tends to be better down there, maybe. But yeah, thanks so much for tuning in. We have some very exciting talks today. Open source things, AI things, open source and AI things combined. So yeah, without further ado, I'll hand it over to Brandon, who will be talking about open source maps and data.
Yeah. Okay. I hope everyone can hear me in the back. You good? Thanks, Thor, for the intro. My short talk today is about map making using open data. I'm Brandon. I'm the lead developer of the ProtoMaps project. A bit of background about me. I started this project about 4 years ago as an open source thing, and I work full-time on it now, so it's my full-time job. I've been working with open source software and open data for about 12 years now. So what is ProtoMaps? It is an alternative to something like Google Maps, but it is totally open source. So it is for interactive web maps. So any kind of application or mobile app that lets you zoom around, that lets you pan around the map, you can use this for that.
Brandon, we're not seeing, I think we're seeing the wrong screen.
You're seeing the wrong screen?
I think you're sharing.
I'm sharing.
Because when you go full screen on the presentation, somehow it's not being.
I just won't do full screen then. Is that fine?
Maybe, yeah.
It's on StreamYard?
Yeah.
Okay, so I'll just do non-full screen then.
Okay, cool.
Is that good on StreamYard?
Yeah, that's good.
Okay, so I'm showing the map again. So interactive maps that you can zoom around, you can pan around. Those are all what ProtoMaps is for. It's where you would otherwise use something like Google Maps. You can use this, and it's free and open source. So how do these maps work? Vary at a very high level. Well, they use a data structure called tiles. They often dynamically or pre-compute what the world looks like at different levels of detail. So at the first level, you have the entire world in one square. And as you zoom in, there's going to be more and more detail. There's like a subdivision of each tile into 4 subtiles and on again, about 15 zoom levels. So basically all popular web maps are built this way. So what ProtoMaps is under the hood is it is an open format for tile pyramids stored in a single file that you can host on something like S3. You don't need to have a web server or some sort of like server-based process to host a map. You can do this entire thing as a single file. And that means you can zoom all the way in. You can use data I provide to have like a pre-computed map that you can host for your business, for your project or anything. But that's like a high-level overview of what this thing does. Where does the data come from is what I'll talk a little bit about, and some new data sources I'm working with that have to do with AI in some vague sense, because this is like an AI meetup, so I have to mention it somehow. Well, when you go to a place in the world and you take a picture, then like iOS will tell you at the top, I am at like Zhongshan Sports Center. So how does it know that? It has to have some data set about the real world. It can't just make stuff up. It has to have some real world knowledge about what places, what restaurants, what what stores and houses and parks exist in the world. So all that data needs to come from somewhere. Usually it comes from a free source, like OpenStreetMap, which is one free data source, but it's like you have a database of different tagged places with latitude and longitude. You could feed those as training into like some sort of foundation model. So you could ask it, what is the place that is similar to this around this area? Where's the data come from? And some people say, well, you could just use Google Maps. You can go pay for Google Maps. But people have like these bootleg products that are like Google Maps extractors that you can scrape the API to have a data set. But those are not going to make your lawyers happy because the Google TOS doesn't let you use their data commercially, even though it is like the best data set and you can use it for free when you go into your app on your phone and look around. That doesn't mean that you can use it commercially for free if you are building your own product. Like if you're building PicCollage and you want to build in some sort of like geotagging, you would have to go pay for Google's API, which might be really expensive if you're a popular app. So Google scraping is sort of out of the question. So what else is there? There is a new project this year called Overture Maps. And this is a collaborative open source project from Meta, Amazon, and Microsoft. And how this works is it is totally open source and you can do whatever you want with it, even if it's commercial. It's under a permissive CDLA license. It is one big file you can just download and you can integrate that into your applications. You can host it on your backend. You can do it whatever, and it's free. Where does the data come from? Right now, a lot of it is Facebook pages. So when businesses go in and edit their business listing, like if you have a cafe, well, most businesses, they want to show up on Facebook, so they will go in and add that. And Facebook is literally giving you all of that data for free in a structured format that you can use for AI models. You can use it for building a visual map. You can use it for photo tagging. You can do anything. How does this work? The front end to this is, the one I recommend is DuckDB, which is an open source, awesome project. It's like a CLI and library that you can just download as a single file. You can access Parquet files, and you can query this data set of about 60 million places by bounding box. So I can ask for all of Taipei with this rough box. You can just write a SQL query on the command line, or you can use the Python bindings. You can give it coordinates as to where you are in the world, and it will give you back like SQL results. You can see that in the data set. I think it's like the data set maybe is trying to catch up to Google Maps. There's, for some reason, like an overrepresentation of like beauty salons, because I think like a lot of people that are like nail salons, they want to be on Facebook. So more of that data is in there, better, like probably compared to like a night market stand. There is 4,000 food stands in that bounding box, 5,000 restaurants. But that gives you a high level idea of what data is in the Taipei data set right now that you can use for free. If I ask for just the bounding box on the building we're in, you can see just changing the SQL query. And it has like the PicCollage headquarters. It has categories for all of these restaurants, or there's like a church, a school. So this is all open data that you can download and you can use for your own applications, or you can use for your own models or anything. So where this comes from is like there's this bistro downstairs, and presumably the business owners, they edited this Facebook page with their address. So you're just getting all of that data without having to scrape it. You're just getting a dump of millions of places that you can use for anything. And some demo apps I've been building off of this data set are putting it into the Protomaps format, which is called PM tiles. So you can go to this GitHub URL. You can browse the entire global data set of Overture places in one map, and you can see what places come from this data in your area. And another fun thing I've been working with Thor on is putting this data into Supabase. So if you wanted to build some sort of database application, like you could go in and you could like add a star rating to this place in your own app. Well, you could all do that serverlessly with Supabase, and you can render it using like Postgres functions, so you can have like thousands of data in one view. So it's totally open source, a data set that I recommend you try out for any sort of application that has to deal with the real world. But I'm happy to talk about using this data set or using other open source tools around this if you guys are curious. Thanks. Do we have time for questions?
I think so, yeah. We actually had one speaker who couldn't make it, so
Okay.
Yeah, if anyone has questions, yeah.
Caleb.
Earlier you showed that the data was coming from Facebook pages to an address. But how do you map the bounding boxes location like to an address?
So the data set, they do that already on their side. So they have, the data set will have a column for address and then also a column for latitude and longitude.
Okay.
So you don't need to do it yourself. It has both. So if you want to show the address for display purposes, you can also show that. That's just a column in the data set that I didn't show there.
How big is all this if I wanted to just get the whole thing and play with it?
It's like less than 10 gigs.
Oh, wow.
So it is quite manageable.
Nice.
And you can, if you use DuckDB, you can just write SQL directly against it. Yep.
Yeah, does the data set include information about the age or like when the Facebook data or wherever they're aggregating it from was last updated, so you can kind of weigh data to see accuracy, or how does it handle also, I guess the second question, conflicting entries that are sort of mapped on top of each other?
So for the first question, they have a confidence score because there is some ML stuff that goes into the final data set. Like the mapping from address to lat long is not perfect. So they also have a confidence score that's just like a float number that you can get some idea of like what are the ones that you can be more sure about. The second question was about the update time. They also have an update time, but that's a little like abstract. That's more probably on their side as to like when the data was updated.
I think.
Yep.
We do have a question from the live stream, actually. So Ron is asking, how does Overture Maps compare to OpenStreetMaps?
So Overture Maps has a couple of themes. And some of the themes are directly OpenStreetMap data, and they point that out in the data set. They will have a source field, which is where the data comes from. So what Overture is they also combine OSM with other data sources. For example, Microsoft put out a buildings data set. Like they have really good buildings in Africa. And what Overture has done is they've combined the data sets. So we're like, if they're mapped in both, you only have it once instead of two buildings. But for places, they have a similar number of places right now as OpenStreetMap. I think that'll get better over time because they're pulling from Facebook.
Cool. Maybe one
more question.
So in your experience where you compare different regions you're familiar with, maybe would you say that this is Overture is strictly better than OpenStreetMap as a data set to work with, or are there some things where it's adding too much noise, or like not as accurate as OpenStreetMap would be in certain ways?
I'd say it depends completely on region. And my general, like, if I had to like make one high level statement, it's like where OSM is popular and Facebook isn't popular, OSM data is going to be better. Where Facebook is really popular and OSM isn't popular, Facebook data will be better. So like in, I think like Thailand, like the Facebook data is probably better than OSM. The good thing though is they release a new data set monthly. So they're also kind of like trying to improve this on a month-to-month release schedule, and also adding in more data sets like as they go.
Cool. Okay, one last one.
One last one.
Is there a change set so it's just you can see the compare the snapshots between this? That feels like it might be a more
I kind of have that built. You could just like open it up in two windows, like load a previous data set and then just like flip back and forth. It would be nice to have like a side-by-side comparison. That's something I do want to like make better, yeah. But I don't think there's any like really good tool for that right now.
Well, it feels like it would be an interesting visualization, right? You showed me, just the single output and just mapping that over time, giving someone a slider or visualize that. That's just me imagining what it would be fun to build with this.
Yeah, I think it'd be really useful.
Sweet. Yeah, please, round of applause for Brandon. Cool. So I was thinking, should we sprinkle like the AI stuff within, or are we doing like not? No, you're also talking about kind of AI, right? So, Michael, do you want to
Sure.
take us through Storybook next?
Yeah.
I sent you as well. I sent you the studio link for the live stream. If you could share your screen there as well.
On Twitter?
I sent it, I think, on WhatsApp.
WhatsApp, okay. All right, I see myself.
Yeah. Yes, if you mute yourself, and maybe also turn off the audio just in case.
Yeah, should be good.
And then you just need to click present and share your
All right,
screen.
let me. Is this Central Park?
Yes, and then 3502. And then additionally in the StreamYard studio, you also need to...
Could not connect to Central Park.
Oh, okay.
Let's try that again.
All right, well, this is going, maybe folks on the live stream, feel free to introduce yourselves and what you're working on.
Cool.
Is this coming out of the...
I don't know whether I should try to turn it.
Is that a mute button? Are you sharing your audio to the...
Oh,
okay. Okay.
it's me. Sorry about that.
And then just in the StreamYard studio, you also need to share your... Sorry. We're like
So many
double sharing, yeah.
devices, oversharing.
Yeah, so
okay.
if you hit present there.
Present here. Okay. Present
Share
the.
screen. Yeah. And then just say entire screen. I think it's not finished yet, sorry. If you go entire screen on the right, yeah.
Right.
Just do, yeah, sweet.
We can do it. All right.
Okay, perfect.
This is a lot of setup for a very short presentation. So this is a little bit more of a conceptual presentation than the previous one. And I am curious who's here for the open source, show of hands, and who's here for the AI? Okay, and I guess we're all here for the meetup. So this was a little bit of a stretch because I am trying to connect Storybook, which is something that has very little to do with AI yet, to AI. But actually, this is kind of a roadmap for the future of Storybook, and it was inspired by this meetup, and y'all are the first to hear it. So to start with, What's Storybook? Have folks here heard of Storybook, used Storybook? Some of you? Okay, cool. So Storybook is a workshop for building UI components in isolation. It works for every kind of major front end and is used by a ton of companies around the industry, like Supabase, everything from small startups to Microsoft and IBM and all those folks. Airbnb was almost entirely written in Storybook, for example. Here's kind of a picture of what it means to build a component in isolation. So on the left-hand side, we have a sidebar of all the components in your UI. In the middle, we have like a sort of a key state of your component. So you can imagine every single UI has a ton of different states, and that's like Storybook is like the catalog of all your states. And then you can do things with them. So you can automatically generate documentation from those key states. So every major design system like Salesforce Lightning or IBM Carbon or whatever, they're all built, Shopify Polaris, they're all built in Storybook, partially because they want to document all those states. You can test those states, so you can write kind of interaction tests on top of your components to get them into hard to reach form validation errors, yada, yada, yada. You can visually test your components. So if you make a change to your CSS or to the logic in your component, it might create a visual change, and Storybook can automatically compare the current version to the previous version. And it's really useful because it's like writing a test without actually writing any test code, and sort of a really surprisingly productive way to get a lot of confidence about the code changes that you make in a UI. And as I mentioned before, I would say it's used by about half of the companies in the Fortune 100 in the US, and then a lot more kind of like cutting edge companies. It's still a pretty new technology. It's been around for about 6 years. So that's like a quick intro to Storybook. I lead the project. My team is in Europe, but I'm based here in Taipei. So I'm a night owl. I work in the evenings mostly. That's Storybook. What about the AI apocalypse? This is where the talk gets a little bit more speculative and conceptual. Because what does UI have to do with AI, really? Well, I would say that AI-generated code is the future, and it's not only the future; it's the present. Like I don't know how many of you guys use tools to help you be more productive, but some notable examples are, GitHub Copilot, which is sort of a very guided and interactive version where you ask it for things and it does very specific things on your behalf. And then to kind of more like guided mode. So this is like builder.ai, and there's a bunch of other tools sort of in the same vein where you can take a Figma design and automatically generate component code from your Figma design. And then to like kind of completely magical code, like v0.dev, sorry for the network quality here, where you can just ask it to make something in text and it'll go ahead and do its best to like create something on your behalf. And so I think these are kind of like 3 levels of AI, one of which is like very supervised and you know exactly what's going on, and one of which is like quite out there. And so like obviously this is really powerful and exciting and will only get better. But it's also maybe dangerous as well, because all of a sudden you're like putting stuff into your code base that you know really no idea how it works and whether it's doing the right thing. And And so like, you know, you see like all these cases here of like hallucinating 7 fingers and 24 teeth or whatever. Like I think there's probably plenty of opportunity for code equivalents of this, where you may have things that look great and sort of like seem good, and you hit go, and then all of a sudden your code has 24 teeth. And so where this gets back to Storybook is that because Storybook maps all the UI state of your app, we actually have a chance to kind of guard against this. Um, and uh, and so the project that we're kind of interested in right now, I'm interested in, is fighting fire with fire and using AI to generate stories to get coverage for your entire application. I showed you guys earlier how you can kind of do visual diffs to like see where things change, and that way you have, whether you have like a junior dev who doesn't know what they're doing and kind of goofing up code that way, or like a virtual junior dev who's doing the same thing, you can basically cover a ton of stuff and have a lot more confidence about your software. And that is all vaporware. So I'm currently, Storybook is all real. And basically, I have a background actually in applied machine learning and was sort of had a different life before Storybook. So what we're doing right now is actually building like a lot of harnesses in Storybook, like the ability to edit those stories visually in the UI, and sort of things that like, imagine you're generating a ton of stuff and you know that it's not gonna quite be right. Like what would you do to let the user kind of have the most control over that? And obviously, it's easy to generate a combinatorial number of states for UI components once you've analyzed them, and we can already do that. But this will be all kind of rolling out over the coming months, and so you can follow me or Storybook on Twitter, and happy to answer questions and chat more one-on-one. Thank you.
We do have time, I think, for 1 or 2 questions, if there are any.
Yeah. Earlier you showed a slide where there was a diff between 2 UI states.
Yeah.
How does it do that?
So basically, like every time you do a commit on a PR, we'll just take a snapshot of all of your stories. We have a cloud system that does that across N browsers and and then it's just like literally taking the image diff. There's a lot of like extra algorithms of like layout shift detection and so on. Like we're kind of adding to make it a bit smarter, but right now it's pretty dumb, and even so, it's like incredibly more productive than writing tests and tweaking tests and maintaining tests and
Like, is it
da.
rendering it, or is it just taking an image?
Yeah, it's just like we use Playwright under the hood. We take a screenshot of the thing and we store it to S3, and we have about 8 billion snapshots up in the cloud that track all these customers. And that's how we make money too. We charge for that.
What underlying model?
Go ahead.
What underlying model do you use to do all this?
To do the AI?
Yeah.
Nothing. No, I mean, so the way that I'll definitely go about it is we have like all the interfaces to your components, and so like the dumbest possible thing you could do is just a heuristic that like does all that. You can ask ChatGPT to do that kind of stuff today, and it can do something a little bit smarter. But like we're kind of taking baby steps right now. So
I'm a big fan of Storybook myself.
thank you.
But I have a hard time getting clients that I work with consulting wise to spend the development time to set up Storybook. Have you explored at all using AI to be able to take an existing React code base and essentially auto migrate it into Storybook? Because I'll tell you that would be extremely valuable.
Yes. So we have a prototype for doing that. One of the features that I mentioned we're building in right now is kind of we're doing UI first and kind of AI trailing. And so in the version that we just released, I guess a couple weeks ago, there's now like a plus button in the sidebar that allows you to just like add a component and auto generate a story for that. That's the kind of the baby step. The biggest thing that happens when you like onboard a storybook, is like you're using a component library that requires like a theme in the material UI, global theme, and so we'll be really focusing on kind of understanding those errors and either fixing them automatically or kind of providing the documentation for you to get up to speed. But then once you're up to speed, scanning through and finding all your components and generating stories actually quite easy. Yep. Yeah.
So for Storybook, how is the open source project sort of like administered? Is it like a company or a foundation, or is it like sponsored by like a nonprofit, for example?
Yeah. So we have a company, and the company provides this SaaS service for automated testing, and that is completely separate from Storybook. Storybook has a steering committee, and it's a community like driven process, but it's a duocracy. And so as the company, like we have a lot of ambitions for what we want to do, and we do a lot, but we also have like 2,000 contributors from around the world who just like want to scratch an itch or are using it for their own work and want to improve it in some way. And then all of that stuff is completely free and open, and there's kind of a wall between the company and the open source side, and the wall is me basically.
Sweet. Maybe one last question. What brought you to Taiwan?
My wife is from Taiwan, and during we met in the U.S. and she was I was a floating location, remote work type, and she had a job here that was flexible, and so we moved here. And for a while, I was kind of going back and forth, and then during the pandemic, I moved here full time and bought a place and had a kid and settled down here. So,
Congrats.
yeah, thank you.
Cool. Yeah, thanks. Please give a hand.
Thank you.
Sorry, Daniel, I'm actually going to go first because I think yours is a lot more interesting and I want to save it for last. So, yeah, I think if we turn that one off. All right. Yeah, actually, I thought that was interesting. I had a question for the audience, like who uses like AI coding tools like Copilot, SourceGraph, V0, like on like an actual daily basis? Wow, that's amazing. Yeah. It is pretty tough to go back from, like, I was on the...
I just turned off auto suggest this morning.
You turned it off?
Yeah.
Interesting.
How many would be very disappointed if it disappeared tomorrow? Raise your hand. Okay.
I was on the plane and I didn't have Wi-Fi and I was very disappointed.
Self-hosted.
I wonder that is anyone use JPAI to do the code review process?
Yeah, I mean, isn't there like Copilot does Copilot do that? Or no?
Because we have a GitHub action that if we send a pull request, the AI will do the code review first, so we don't need to do.
We did that, but it's too expensive.
Oh, okay.
It's really
Cheaper than an hour.
it's cheaper than you know, like GPT always give you really this thumbs up, and you're doing really great. You convince try forward pull request because you just fix the one typo.
You didn't pass in the whole code repo.
Not just a change.
I see.
So you still need code review. So they-
Yeah. But
They encourage you to do small typo review. I mean, typo changes.
I don't think so. It still works great, and you can even like find potential security there.
Cool. I guess I get a...
But have anyone used code review?
No.
Just me?
I will try it. I will try it.
Cool. Yeah, I got to figure out the AirPlay. There we are. Maybe make that bigger. This is me. You're very welcome to follow me on Twitter if you want to hear my ramblings, or if you want to know if the pizza has arrived. Earlier, it did arrive. Yeah, I'm Thor, or Lei Sen, my self-given Chinese name, Thunder God. It was, I thought it looked pretty cool. I do developer relations and developer experience at Superbase. Actually, I'd love to get a show of hands, like who has heard of Superbase? Okay, so who has used Superbase? Keep your hand up. Okay, that's very cool. Is it working roughly well in Taiwan, or slow on the free plan? Self-hosted. What do you host it on? In your room.
And a VPS that we have as well.
Yeah, that might be fast then. No? It's like no latency whatsoever. Okay, that's cool. I'll send you an invoice in a bit. But so I'm mostly based out of Singapore. I do love any good excuse to come to Taiwan. Really love it here. Who knows? Maybe would move here eventually. But I am a gold card holder as well, and thank you to the Digi Gold Card community who is actually supporting this event. So the pizza sponsorship is from them, which I think in the end means it's from the Taiwanese taxpayer. So thank you all. If you're paying your taxes in Taiwan, thank you. I also do this little passion project of mine, which I call Hacker House Taiwan. We did one earlier this year, just before Lunar New Year. We brought a bunch of remote software engineers together, actually exactly in this space, just because, I have one friend who's at PicCollage, and they've just been so kind to host us here. So again, also, thanks PicCollage for hosting us today. Really, really sweet. And yeah, I'm hoping to do more Hacker House Taiwan edition. So if you're interested in something like that, follow it on Twitter. You can also, if you go to the blog post, there's a form, interest form, where you can put in your interest. Cool. Then also I'm one of the 2 GitHub stars that we have in Singapore. I have no idea why they chose me, because I'm German and I just happen to live in Singapore, and somehow they gave me the star. But I actually think there's better people, so I should really put them up. And yeah, I used to do things at Stripe. Before I went to Superbase. So Superbase, I guess, since you all kind of know what it is, don't really need to go through too much. Really kind of built on top of Postgres, everything open source, interconnected, kind of the authentication lives within your database, edge functions as well. The JWT is sort of integrated into your file storage. You have a real-time server. And then most recently, you have something called Vector. So really what it is again, it's an open source Postgres extension. And this is really what makes Postgres so powerful, is that you have this extension ecosystem. So, someone built this PG Vector extension, which actually brings Vector capabilities into Postgres. Actually, do folks kind of know Vector embeddings, like how that stuff works? Sort of, yeah. I mean, if you don't, there is actually Superbase Vector embeddings. There's a good blog post by. Is it this? No, this is not the blog post. Where was the generate embeddings? Somewhere there's a blog post about it. Is that the blog post? Maybe I need to, because there's a good visual that I wanted to show. Vector search, no. Wow, and Taiwan is giving me everything but the result I want. Anyway, so really what vectors are just a way to translate sort of human context, like speech or images, into kind of machine context. So vector really is just an array of numbers, depending on how many dimensions you have. There's more numbers. And basically what that then means is that you can perform similarity search of finding context that is similar to other contexts. So for example, if you're searching, doing like image search, so you create a vector for your image, and then if you search for something that is similar to the context that's in the image, the vectors are in proximity to each other. So that's kind of how the vector stuff works. Now, what I actually wanted to show you is, now I put AI in the browser, I think in my talk title. Now, I haven't actually been able to play around with it ahead of this talk. So Transformer.js is a really interesting project that like the folks at Hugging Face are working on to actually run sort of web GPU things in the browser. That's pretty cool. But what we're doing at Supabase is to actually run inference as well as later on kind of large language models within your Supabase edge functions. Now, edge functions are kind of, these guys here, just small JavaScript kind of isolates that are, quickly spun up all around the world, closest to your users, which means, there isn't really a great way to sort of do AI within them. But we've actually sort of preloaded a model here. So in this case, it's a GT small model. It's a model that works on, I think, 380 dimensions. So fewer dimensions, but still apparently fairly good accuracy. And so what you can do with this then is that you can generate an embedding, for sort of all your, okay, this, is it already spun up? No, it's not. Okay, I shouldn't be doing live demos when I came from a red-eye flight. Maybe we stop this. Is this the project?
Interesting. So it really means that you can you store it into the embeddings vector right away in Supabase.
Yeah, so what's pretty cool with the edge functions is that you can, so you can use kind of database webhook triggers to actually, like trigger the edge function based on an event in the database. So say there's a new row inserted or updated or deleted in your database, you can then trigger an edge function to run kind of whenever that happens. Yeah, okay. So now we're starting this up. So with Supabase, we have, that's kind of a nice byproduct of everything being open source. You can actually run it locally using the CLI, which is pretty nice. And so this function is a database webhook. So we have a table. So if we look at our migrations, we have a table called embeddings. And basically anytime we insert kind of a new row into that table, we then run our generate embedding method, which then uses kind of a preloaded. So we basically have the GTE small model sort of preloaded, so you don't need to pull it down. Previously, you were kind of pulling it down from Hugging Face, which had kind of a lot of overhead. So now we have that kind of preloaded into your Edge runtime, and then this means you can just generate that embedding, and then we basically just write that embedding back into the database. So if we open up our Supabase Studio, for example, we can look at this. Here's our embeddings table. And so basically we have, kind of our content in here. And then we have our embedding, which is the vector representation of kind of the context within that content. And now when we insert, new content, say Taipei, then it will go off, fire off. Now I'm running it locally and I haven't set it up properly. So it's actually not running locally at the moment. Yeah, but in theory, it would then go and write the embedding in there. Anyway, so then we have another method, and so this is kind of how we perform sort of this proximity search. So we have embedding vectors for all our content. So for example, in our case, we actually generate embeddings for all our documentation. And then you can put, so in the Superbase docs, you have this here where you can say ask Superbase AI, and you can say, okay, how do I connect to my database? And so now we're generating an embedding for this phrase, how do I connect to my database? And we perform a proximity search through all our documentation content. And then we use that context and give that to OpenAI to then construct a markdown answer that we then kind of put in here, custom. So that's sort of the idea. That's the same what we're doing here. So we're getting our search term from our request, and then we're creating embedding for it. Where will we create the embedding? Search. So yeah, model run. Okay, what is model? So here we go. Model run, that's how we generate our embedding for our search term. And then we have our embedding. And what we have here is a remote procedure call to a Postgres function that's called query embeddings. And this is our function here. So this is sort of how PG vector, so we're using our embedding vector, 384 dimensions in this case. And it's basically using this here normalized length. So we're using, it's called cosine similarity to basically get, the context that is most similar to our search term. So this is really where the magic kind of with PG vector comes in. And so now what we can do is we can run maybe our function. So we got Superbase start already there. We'll do Superbase function serve our function. So again, the Edge function runtime is open source. It's built on top of the Dino runtime, which is also open source. So we can run it locally as well. And then we can do a curl request here. And, so the context basically now we're searching for, vehicles in our database. And basically we're getting back, okay, in our database, we have a car, we have a boat, and we have a train, right? Now, the cool thing is, right, so if we actually have things, where are we here? So for example, if we have, we're searching for things that are edible. Is that how I spell edible? So it'll give us banana, tomato, apple. That's good. Now, Apple is not just Apple, it's also, an electronics brand. So if we do the same and we search for electronics, we also get the Apple and the car. The car has electronics, right? And the desk. So this is where this becomes quite powerful, where actually the entire, not the entire human knowledge, but like human context is sort of encoded in those embeddings. And sort of this, we kind of call it semantic search, becomes actually quite easy to implement. And yeah, I think I'll stop here because I didn't have enough sleep. But yeah, there's plenty of videos as well about kind of different AI things. And we're also, I have an example where I'm using OLAMA running locally, so large language models running locally and then calling that from our edge functions. And that's quite exciting because that sort of is a perfect transition into Daniel's talk. And so without further ado, we'll do that. So thanks so much. Cheers. But yeah, if there's any questions. Yeah.
For the edge functions, can they be run? It's Super-based open source, right?
Yes.
Can they be run in Lambda or like cloud functions?
No, so the runtime it's a Dino runtime, but you can host the runtime yourself.
Okay.
Yeah. Yeah. I mean, if you want to use Lambda, like you can cobble that together as well. But yeah, so generally what you would do if you're self-hosting is you would just host the runtime yourself. Yeah. Cool.
Did I do the setup correct?
Yeah, I think we're looking good. Give me 1 second. I'll switch the camera over to you. We'll get your mics up. And then actually we have your screen twice.
AI generated or
Yeah, it's stable diffusion.
Okay, if you clip that on you, you can probably just clip it on.
This is my first talk, actually in a very long time. Yeah.
I just listened to your talk like 2 days
I
ago.
answered 2 questions. I actually haven't given a technical talk for like, we've been holed up since like Llama came out on February 15th. And I last saw like Allison like a few years ago, February 15th. So hi, I'm Daniel. So we're actually based in Singapore. So last year on January 18th, my kid came. On Llama was released on 15th February. And basically I've just been like holed up coding, rather getting the AI to code for me for the last 1.5 years. Oh my God. Okay. So yeah, and I think we're both actually open source as well as AI. So maybe I'll just do a quick demonstration of what we've built. So a little bit about us. We basically were model trainers. We basically train a bunch of stuff. We basically fine-tune a lot of models, tried training a few foundational models, didn't have enough money. So we started doing a lot of fine-tuning on Hugging Face and all that. That's who we are. We're back-end AI engineers, really focused on the mathematics of it. Everything that we did, nothing grew, except for one. We launched a stable diffusion thing in July last year. It went viral. Actually, a lot of people used it from Taiwan, up until I decided it was a great idea to see what are people like generating, right? So I clicked into the folder and I was like, oh boy, okay, we're gonna get out of this business, right? Because they use it for generating quite interesting things, right? So yeah, but I think after that we started to build a bunch of stuff. So we built then one of the other experiments we built in a local AI thing on the desktop. We built it. Today I think it's about, oh wow, we had 19 stars. Oh, that's more. Okay, we have like 1,000 forks. So I think everybody's like taking it and using it for their own projects and all that. But we're not UI people. We just built the UI to show off what we were doing on the back end. So I actually tried to do a storybook. I couldn't figure it out. And then ChatGPT wrote the rest of the UI, and that's sort of what we've done. How does it work? It's something very simple like this. So you just be like, tell me more about life or something. And this, if I turned off the Wi-Fi, this essentially works on your computer on commodity hardware, and it generates AI. So most people know Ollama. Most people know LM Studio. We're the bootstrapped open source version of I think LM Studio. And I'll share a little bit more about some things that we're doing. So this is what LM Llama 3 8B Q4 thinks about some of this. So yeah, we have some interesting stuff. So I think for us, we're a bunch of open source engineers. Many of them came from me from my previous company. We're just holed up, really fascinated by this technology. But we've actually come out now as the homebrew computer company. That logo was actually not designed by Stable Diffusion. And I think we are, a research institution that's really, really interested in AI and just building things up and down the stack. Okay, so I think before I bore everybody, I want to just do a rough gauge of where everybody is in terms of your technical knowledge, and then I can scale it up and down depending on how you guys want. How many of you have used OpenAI's API before? Good, wonderful. How many of you have run a local LLM? Wow, this is one of the best, actually. Okay, how many of you have run an LLM in production? Okay, how many of you have built your own computer? This is a very technical group. Built your own server. Damn, you fine-tuned your own model. Trained your own model. Worked with multi-node GPU clusters for inference and fine-tuning. Okay, so I'm going to bring this talk a little bit deeper because I think you guys really understand your stuff, and I think we want to drive on this. What is Jan? Jan is basically a UI that's sort of nice on top of all the other stuff we did. Was it difficult to build a UI? No. Did anybody use our software before I built a UI? No. So, after all these years, I've just realized that we've got to learn some React and get with it. Okay, so but I think a bit of the fundamentals, right? How many of you guys understand how a transformer works or the LLM works at a mathematical level? Okay, so for those of you guys, I'm going to keep this talk, I think, a bit higher level, and then later we can go into like really the meat and potatoes and the math side. What is an LLM? Basically, the way I think about it is that our human brains are biological neural networks. How the machine does it is a really shitty version, digital version of a neural network. Is it great? Not really. Does it work? Yes. Can it hold a lot of data? Oh, hell yeah, right? And all you need to know for the purposes of this talk is that an LLM basically just, when you use an LLM, the first part encodes it in machine speak, right? And then it runs through this thing, which is like a neural network. Do you need to know, understand, and how it works? Not really. The only thing that you need to know, and then after it runs through the network, it thinks in the same way that our brains think. And once it comes up with its answer, it then gets decoded in whatever language or vocabulary it is out there. For the purposes of this talk, which is focusing on the machine and the hardware itself, the only thing that you need to know about this neural network is the layers, right? And that'll become important for later. Okay? Another piece of fundamental knowledge, what is in a model, right? When you say I'm running Llama 3, what exactly does it mean? And the reality is that there's so many different versions of Llama 3, right? Because when we're running it and all that, you have Llama, okay, this one's an outdated slide, Mistral 7B, 7 billion is 4 gigabytes, but this Mistral is 24 gigabytes. Why is it so different, right? And the answer is really in terms of the parameters, right? Think about parameters as just really the amount of fidelity, the sort of size of the neural network, right? And the more parameters you have, the better. The other thing is also the quantization, right? And this is, I think, a bit more mathematical. What you need to think is essentially these neural networks operate on like integer and operations and all that, right? So if I asked you, what is 4 times, Brandon, what is 4 times 3? 12, right? And what if say, what 4.1621, 4.1621,317 multiplied by 3.162171? You say, okay, I got to do a bit of math, but it's going to be around 12, right? Okay, I mean, just so what it is that essentially for quantizations, you have a very large floating point that has to be computed over here. And it is possible to actually reduce the fidelity or you round up in certain versions to make it a bit faster for that computation to happen, right? It makes it a lot faster, but it's still very approximate. It gets roughly there, right? So these are the two important things that you need to know about models. So the bigger thing about all of this is also that these models don't follow a linear curve. When you have these parameters, and okay, I'm making up the human stuff over there. I actually have no idea how many parameters we have, right? But I stole this from the instruct eval GitHub. If you look at over here, MMLU is a reasoning, think of it as an IQ score for machines, right? And what happens is that in the number of parameters that you have, what you see is that, yes, it gets smarter, but it doesn't get smarter like this. It gets smarter like this, right? And that was what was so interesting. If you download Llama 8B today, and it works on your computer right here, and in your system monitor, it is a 4.5 gigabyte file. That makes your computer a thinking machine with almost a full knowledge of humanity available to you on your flight. And this is going to be in your phones before the end of the year. But your phone might get really hot. Okay? So turning back to this, so intuitions again, right? So unsurprisingly, bigger models need more GPUs and hardware, which is why I think I'm here for Computex and why Jensen Huang is making so much money over here, right? And so those of you from the hardware sides, if you just look at this and the amount of VRAM that's needed, it really goes up further and further. And okay, we left out two of these labels. This, I believe, is FP16. This is int4, right? So the quantizations also matter as well. Okay, so, and what does this mean, right? So I'm in Taiwan, so I realize most people here are very familiar with hardware. But what this really means, and when in the Valley and all that, most people have never actually opened the machines, right? And what it really means is that, okay, how many GPUs do you need to run Llama 2 70B, right? For the 3060s, okay, nope, that's not working. Tesla V100s, you need 16. For the A100s, even for that, you need 4 of these guys, right? So these are not simple machines. This is actually what we built Jan on. It was in my room, just heating up the baby and all that. And you have only 7 PCIe slots over here, right? And once you get to Supermicro and all that, you see, okay, you've got 4 here, the number of PCIe lanes are also there, right? And that really means that AI is really, truly a hardware problem, right? And how do we build software, and more importantly, open source hardware and open source software around these problems? Okay, so my problem was really, I woke up, I was like, oh yeah, Llama's released. All right, let's go run it locally. It basically became this hardware adventure that we've never quite gotten off. And so now, big picture again. In the news, you will hear about teraflops and all that. Teraflops is basically how many floating point operations can these machines do, right? And more importantly, what we're finding is that memory bandwidth is really, really important for faster inference. So within that GPU, how fast can the little cores in there talk to each other, right? And why is it important for us as algorithms guys? It's really because all the new algorithms like flash attention, which essentially takes an algorithm which has 6 or 7 read and writes from state, and you're basically applying linear algebra. You're doing it's essentially all of these techniques are hardware optimization techniques. You're figuring out which things you're keeping in HBM and what you're tossing into SRAM, right? So it's to that level of detail that the algorithms guys can't just say, okay, my math works. Here's my paper, I give you my PhD. We've got to really start thinking about, okay, where exactly are we putting the data? Because that is the difference between a 30-second inference request and something that returns in less than 4 seconds. Sorry, 0.4 and 0.30. No, 0 and 3.0 versus 0.4. Sorry, decimal error. Okay, so again, I'm not sure where everybody is in this. I'll just cover this. So laptops. So this is an overview of computing, right? Laptops, usually they have most of them don't have GPUs. Those that do have it here. Your good friends at NVIDIA and all of them manufacture it here. Apple Silicon is interesting. There is no separate GPU. Instead, it's a system on a chip. And they use the unified memory of RAM to basically run all of this. And what is super interesting, last week, Windows announced the Copilot Plus, where essentially, I didn't know, I had to read, I drew this diagram for myself. I'm not sure whether it's correct. So if anyone from Qualcomm, or even know somebody at Qualcomm will help me out. What is super interesting is basically it's this architecture, but they're sort of migrating it over here, the MPUs and all that, right? So it's going to be really, really, really interesting. And this is going to mean a lot of innovation and almost insane competition, which we're super excited for in the next few years. Okay, desktops, workstations, very, very simple. You basically have a big ass motherboard. You plug, 2 of Jensen's favorite things in there. It might crack your motherboard, it might not, but you just plug it in there. The motherboard is used to communicate between the GPUs unless you have NVIDIA's NVLink that links them up in there. Servers, what does it mean? It's basically the same thing, just more expensive. They use better parts so you can run it for 24/7. And it's support, and if you use Intel, there's support for multiple CPUs, right? So this is pretty much an outdated version, the P100s, but you can just think of it as really a computer that is really souped up, right? And what's really interesting is the multiple servers or the multi-node computes. This is what ChatGPT and everybody uses to run that inference, right? And so what you have is actually, instead of using a motherboard to let the GPUs talk to each other, these bad boys use Ethernet or InfiniBand to talk to each other. Honestly, I don't understand this stuff. It's not our area of specialization. I'm here to actually go to Computex and try to learn this stuff. So if any of you guys know, I'd really like it. So yeah, and these SuperPod is basically interact networking. How does it work? I have no idea. I got these diagrams from NVIDIA's documentation, But yeah, so okay. So what is the talk that we're giving here, right? And I want to just explain, I think, something that we've learned, right? So as of this week, I think Jan's been downloaded 1 million times. And the mark of a true bad engineer, we have gotten at least 86,000 crash reports. And that's only when we activated crash reports, like 3 months ago. So we've been very, very consistently failing and disappointing people for the last part of 1.5 years. So yeah, and so we pull stuff from Jan. Increasingly, I'll talk about this later. We're pulling it out into a library. But holy crap, this thing is really in its infancy, right? And we are so early. If you're hearing me talk about this, this is super early. But I'm willing to bet that what we think of as computers 30 years from now will be very, very different, right? They'll be more human-like, and this is really the early days of, I think, how all of this is coming. So I want to explain a lot what we've learned from a lot of those errors in context of like an inference lifecycle request. What does it mean when you ask a computer to think, when you ask ChatGPT to think? What exactly happens at the hardware level and the software level, right? So this is a story of a prompt. Thor, can you give me a prompt? Pretend I'm a machine.
Generate an image.
Oh, no images, just
No
text.
images.
pretty stupid model.
Or do like a chat completion or just like.
No, just pretend I'm a machine. It's not hard.
Okay.
I can do that.
Yeah.
Tell me a joke.
All right, so tell me a joke. And the best, actually, that's live. I feel that's the hello world of AI, like. So what happens? You tell me hello world, and I'm like, all right. So I'm the CPU. I go down to my hard drive. I take out that model, right? 4 gigabytes of it, and I bring it over to the CPU. And over here, and just showing you my diagrams here, this is what the computer looks like. For those of you who have never had it, I met a Gen Z the other day who was just like, wait, laptops? I was like, okay. Yeah. The Gen Zs like continually surprised me. They didn't know there was like Wi-Fi, there was like Ethernet. I was like, oh my God. Nice. Okay, so then you took this stuff and we load it over here. And this is the CPU, this is the GPU. This is sort of our version of the state diagram. So yeah, and all that. So you're loading it from the hard disk to the CPU. And then the CPU and GPU then pushes some of the model layers over into the GPU. And then what happens? And so this one, certain layers are pushed into the GPU. For the rest of this talk, I'm just going to assume that they're putting everything into the GPU. Okay? And then what happens? What happens here? This is very, very important. That memory bandwidth and that speed of memory movement within the GPU as well as the RAM matters because it then gets pushed into the memory of the GPU. And what's so interesting about this is that it's almost like seeing 2 different computers. You have the traditional computer, which is over here. And then you have, Jensen Land, I think, over here. And that's so interesting on how that happens, right? And then what happens, tell me a joke is run in using a prompt. And what happens is that this one all happens in the GPU, more algorithmic. It gets tokenized into the machine language. And then it gets run through the transformer layers. And all of this is happening right here. Okay? And then the prediction is made. And then it passes it back to the CPU. And usually it's decoded and all that already. To then decode it and pass it back to the user in terms of, so the joke is, actually, I don't have no jokes for you. You gotta ask the LLM for that, right? So this is essentially what's been happening when you push it into the GPU layer. It makes that and it comes out. So that's the easy one. What happens if you have multiple GPUs? Or what happens if you have a model that doesn't fit into one GPU? This is where the math and the hardware come together, right? What happens here? Same thing, the CPU does. It loads its weights and all that, moves it from the hard drive. And then this here is really interesting. It then it distributes some of the layers to GPU1. It distributes some of the other layers to GPU2. Remember, it's not the whole thing. And then inference request is run. But here's the thing that is interesting. The way that Llama does it right now, Llama 3, at least to the best of my knowledge from like running this thing, is that it actually does it semi-sequentially, right? If you look at linear algebra as aggregative, so it computes some of it on GPU1 and then it passes it to GPU2, transforms it over here, and then only after the two of them are done, then they come over. There's this sort of function that's, this very, very high level abstraction. It does this sort of operation over all of the inputs that were given that eventually come out over in GPU2, and then there's the prediction over here. But this is why the communication is so important between the different GPUs. And we've measured it because we run an eGPU and we run like 2 GPUs plugged into the motherboard. So there's a Thunderbolt cable versus, a PCI connection. And the difference is like astonishingly slow, right? And this is so interesting because I think how we build computers is going to have to change if this becomes the primary mode of compute, right? For most of the world's population. Most of us in this room are coders, right? But the vast majority of the world is going to be able to interact with computers and get computers to do stuff by just talking to them. So I think this method and mode of compute will increase a lot in the years ahead. Okay? So now this is the part that I don't know anything about, but I found some good diagrams to show you guys. If anyone wants to step in, please do. I call it my holy moly part of the talk because I have no experience. I don't know how it works. I just read the stuff and I'm like, So what happens? So just a quick refresher, there's the multi-node stuff. And this is basically what NVIDIA's documentation gave me. I'm just giving it to you in full. I have no idea how it works, but just come with me. The CPU, some poor little CPU out there who's like tanking this entire thing on behalf of their entire huge wardrobe of like servers, takes the model weights out of the thing and he says, all right, you get some model weights, you get some model weights, you get some model weights. And it gets distributed across that entire wardrobe of like GPUs, right? And then the part where you hear about NVLink, you hear about InfiniBand and all that, that's the super critical stuff that is about the intermediate communication, where they're sort of exchanging the results, taking the softmax attention, feed-forward layers, and passing them between the different GPUs, right? And then finally, some poor guy one of the GPUs in there has to it's a little bit like school homework, I feel, It's like, you're like, all right, you think through this, you think through this, you think through this, and then they pass it back, and then the poor guy, is got to figure out how it all turns out, and then it gives you the final prediction, right? And if you think about it, LLM models are essentially the same across all of the different types of hardware. It's just the sheer scale at which all of them operate at. So again, I have no idea what any of this is, but I just thought I'd put it here. I was hoping someone in the audience could help, but I think, and this is essentially what many of us in town for to learn, I think, about Computex and how does the DGX GH200 work. Okay. Another just very, very quick part of the talk, the LLM inference ecosystem. And we've done a lot of trying to think through and navigate our way around here. Right now, I think one of the most popular things out there is Ollama. Ollama is essentially wrapping llama.cpp. And basically then what happens is that Llama CPP is a cross hardware sort of inference library. It then distributes it to the different computation drivers. Each of the major hardware manufacturers has their own. I'll pass it down to the hardware driver, CPU, and the machines over here. For us, we actually started out, so I think a bit of programming here. I think we started off Llama CPP, built it for TensorRT LLM for some of our enterprise customers. And now what's really interesting is the Windows Copilot stuff. It runs on this thing called Onyx Runtime, which has always been sort of under-maintained, but it's really, really, really interesting. And we're actually doing our first release of Cortex, the backend library, around Onyx Runtime in probably 2 weeks or so. It's not ready. I'm actually going home tonight to write the README, so just watch it on GitHub. NVIDIA's ecosystem, and each of these, essentially the main takeaway that I want you guys to have is really that at the end of the day, when you have these machines, there's really so many different layers of drivers and stuff that are dependent on. But all of it runs down to the same fundamental few things that it's about how do you make mathematical operations on hardware just go faster. Okay, NVIDIA system, just giving you guys a high level. Intel also has their own, right? What's really interesting about Intel's is there's this Windows Direct ML stuff. My prediction over the next 6 months is that space is going to be the most interesting to watch. AMD has its own as well, its own walled gardens here and there. And then Apple is the ultimate walled garden. They just don't have anything other than their own stuff. You've got to just work with, all this stuff. But what's really interesting is Apple's unified memory because it works on your iPhone and it works on your computer. when we first released, we actually released on the iPhone. And this was like July last year, and I just kept getting reports of people's phone overheating, and we had to like take it down from the App Store after that. Okay, and I think what's really interesting, again, I talked about DirectML. That's the web GPU stuff, WebNN. That's really coming very fast and furious. I don't understand enough about it, but it's really coming very, very, very quickly. Okay, so I think just a little bit about us. I think we're an open source team. Just actually a few people. We used to do model data set consultancy. We built this. Cortex is the one that I wanted to talk about a little bit. We also do assemble GPU servers and inference machines in Singapore. If you know anyone who wants to buy some, or you want to just play some of this, our cheapest machine is under $2,000, and it runs Llama 7, Llama 8B. Yeah. So, but secondhand GPU. Okay. So what are we doing now? It's really, I think, Cortex. What we really wanted was to build a on-device AI that runs, on any type of hardware. We've built it in C++ because most of the traditional AI libraries are really in C++. It was a holy war fought in my team between Rust, Go, and ultimately it came out as C++. And I think, we've learned certain things from Ollama. It's really very nice. I think what we really want to do was to support multiple engines because we think that this space is still growing very rapidly. And, I think for developers, it's really important. Our path as a company is really weird. We built a developer library. We're not in San Fran. Nobody used it. We built a UI. Now everybody doesn't want the UI. So that's life for you. We think that in the future, a lot of this will run on like robots. And that's why local AI, if you think of R2D2 or C3PO, I don't think any of them were like, all right, ChatGPT API key, and it's like, all right, stop shooting me, Darth Vader. And I think where we are really trying to bring this is actually as a full open source replacement for OpenAI's platform. Most enterprises today are used to OpenAI's platform. There's function calling, runs, fine tuning as well. We're basically going to build the exact same thing, fully open source. And we believe that the future of AI needs to be open source. It needs to be understandable and auditable. And what we are going to do is to make it so easy for enterprises or anybody to just switch over. Or if you're a small startup, we really love, and we came out from this community, and we want to really support that. And my goal is basically to take all the complexity and all the pain that we have felt in the last 1 year crashing on random distros of like Linux to like AVX2 processors from like 2006, right? And it's basically just replaced with this very simple library that we want to use to drive the open source stuff. For us as a team, I think the software sides are honestly a labor of love. We don't get paid for it. We just run it because it's necessary. If you do know people who want to buy AI PCs or GPU servers, that's how we feed the team. Okay, so last question, I think people always ask, what computer should I buy? And we've done all the perf testing. Actually, today, the best one is the Apple, actually it's not Mac Studio, where I think you get to run, I think, really, really big and awesome models at the cheapest price. So I think that's our talk, and hope it take away a lot of the mystique of AI and what you would just realize it's something that runs on a machine. And I feel tinkering with it, playing with it, is really what we want to encourage. So yeah. All right.
I think we have time for some questions.
Yeah.
What do you think about 1-bit LLM?
Sorry?
1-bit.
I heard about it. I don't understand it. I don't know, but we'd love to figure it out, actually. Yeah. The BitNet stuff, is it? The BitNet, yeah. I tried reading the paper. I didn't have time to understand it. If you do, I'd really like to talk. Yeah.
I don't think so.
Oh, no. Yeah.
I'm curious, like, this was a great kind of overview of the whole pipeline. And this is all for the inference side. And then there's the whole training side, which is like a different beast. I'm curious, like, I know nothing. I know a lot about the backgrounds of like machine learning and so on, but very little about the current state of the art. Is the gold rush in the inference side or the training side or both? What's the
gold rush,
relative size of these two different kind of?
It does feel that the gold rush is everywhere.
Everywhere.
But there's a lot of bullshit. I would say the fundamentals have not changed. It's still the same math. It's just like 10 new pieces of vocabulary, and you're just like, hey, you can't. And I just feel like nothing has quite changed. It's just that there's a lot more nomenclature. The same thermal limits, everything's still the same actually.
But like, would this talk like be easily translatable into kind of
Fine tuning.
the training end of it? No.
Oh, it's a completely different deck.
Completely
So,
different.
so I think the big thing about LLMs is really okay. So train is very different from vision, right? Vision was actually a very different beast to deal with from LLMs, because the big thing about these LLMs is really that they need to have context of each other, right? And context is basically an n squared problem, right? Because you're trying to figure out how everything relates to everything else. There's some, I mean, and whenever a researcher says n squared, every PhD is like, yes, I can find my PhD by doing a log n thing. And so there's some optimizations, but I would say that that's not a solved problem.
So I've been following you guys since you were Nitro before
Oh.
Cortex.
Oh dear, that was embarrassing. Oh, thank you.
At the end of the day, there actually aren't that many players. You're saying it's super early days. The question is, in some ways, Cortex to me feels like it's sharing a lot with Llama CPP. Right?
Yeah.
And what's the differentiation there? When,
Yeah.
Essentially, that OpenAI kind of equivalent API already existed in some form, right? So what's your vision beyond that?
So I think for a lot of us, we actually are Llama CPP contributors. I think that's how many of us. If you think about Llama CPP, it's basically just implementing it in C++, and then your flash attention and all that comes in. I think where we really see a interesting angle is, I think, really in the if you think about Llama, right? There's two parts. There's really the model curation side, that is somewhat interesting, making sure that it's downloadable, it's Docker, of that stuff. On the inference side, now I'm talking as an engineer, not as a business guy, right? And there's a reason why it's free. Engineering-wise, it's not that tough, right? You're just basically writing adapters, and whenever someone breaks something, you're like, you provide first-level customer support. But we do think that there's something quite interesting about this sort of abstraction layer that allows a enterprise or anybody used to OpenAI to switch very easily to open source AI. Otherwise, there's too much friction and all that. And more importantly, if you're used to a singular, I think, simple, and I wouldn't say Cortex, I think honestly it's like the OpenAI API, and it being able to run on any type of hardware, and this is going to get tougher and tougher, allows for that sort of these simple frictions. It's a little bit like, we did all this backend engineering, and then the UI is the one that got downloads. And now I'm just like, yeah, you know what? I'm just going to do what works. Yeah.
I know that you guys had a hardware focus until.
That's how we pay the bills, man. I gotta pay the bills. Yeah. Connor? Oh.
Kind of continuing on with this question. So from the developer experience point of view, if we're, say we have like a high-end Mac, Apple Silicon, where we've got Llama, which we're using to pull down not just Llama, but Mistral or whatever model. What's the user experience difference between that and your product?
I see. The user difference is really like for Mac, most people will use Llama CPP, right? And for us, I think we've done some optimizations. I think we are anywhere, I think someone posted on Discord or something today. I think we're anywhere between 1/8 to 1/8 to 40 tokens. They do 38, we do 40. So that's speed, right?
I mean the model itself, I mean just the experience of pulling down the model is like pretty good.
So I think it's very similar. My point of view is that that's actually a commodity. Everyone's going to have that. Where it's really going to pull away from is really when you have to support multiple engines, right? That's not easy, right? And TensorRT, let's just take TensorRT, right? Do you do pipeline parallelism or do you do tensor parallelism?
I just have a subscription to all of Manning, and so I'm going through books and learning stuff. So I'm just playing around on my own machine.
But yeah, even like full Llama and Windows, you have to go through like the Windows 7 too. Right?
Yeah.
I think.
Yeah, you can't. They have a Windows preview, but it doesn't use GPU. So
They do use the GPU. I think they patched that. But I think.
But that just goes to your point of like the supporting the different platforms.
Yeah, the more difficult part is really how do you provide that consistent experience across the different things, right? So Llama is really, it's the UX. Why everybody, and I think this is the thing that we learned as backend engineers, it's really the UX, and yeah, like we basically figured this and this out, which are really hard. And then we were just like, okay, so we just need to do like Cortex pull. Sure, we'll build that, so it's gonna come out next week. But like, okay, for like Onyx runtime doesn't have flash attention. That actually has a lot of differences in terms of, how that inference is done. TensorRT is where it gets really interesting because Ollama right now, you can't use multiple GPUs. So it's very, very limited, right? TensorRT will force you to have to dig into the guts of the model, figure out how you want to distribute this between the two layers. Yeah, the two layers. In this case, this is sequential. And maybe brief primer, pipeline parallelism is somewhat more like sequential. Tensor parallelism is where it's really distributed across this. But your algorithm needs to be designed around those principles, right? And yeah, so I think it's going to be a very, very, very interesting area for the next 3 years. Like what we're dealing with right now is just commodity, it's the easy stuff. The pain is yet to come. Yeah. Questions?
Yeah, I'm curious, my understanding from a more software guy's perspective is that a lot of Apple's efficiency really comes from their unified memory. I guess I'm trying to understand, are there products out there that are also building on the ARM platform and utilizing, unified memory, since that really does seem to give you, if you're just working with like, pretty standard hardware, it seems like one of the winning solutions right now. And I'm just curious if there's any other players in the space who are building on ARM using using unified memory.
I'm here to find out. If you want to go to Computex and find out with me, I'd love to go with you. I think the honest answer is that I think, the unified memory stuff is really the correct way to go. At least from all of the stuff that we've done, it's really, I think, the correct way to go about it. So I think that's just sort of where we are. Dude, you've done everything before, so
Yeah, no, the one thing I haven't done is basically train LLMs, but I was wondering, building on the other question, we were talking about having more memory. Of course it does, but what is it, how do I phrase this? For inference, is having a larger virtual, like a GPU memory more important than having more tensor cores?
Oh, yeah.
And do tensor cores only come into play when you start to train your own models?
So I'm not the expert on that. The high-level understanding that I have, right, is really, or rather we've been so GPU poor that we never had enough tensor cores to actually see the difference, right? So I gotta be honest here. So if you're asking me like H100, they've got like tensor cores for days. What happens? Well, it goes a lot faster, So I think especially if you look at LLMs, it's very clear. Let me just show you, I think, a breakdown of LLMs, right? That the space is cleaving into two different types of products. You have these sort of 8B, 7B models that can actually do quite reasonably. And they are 4 gigabytes, 6 gigabytes, 8 gigabytes quantized. Those, fit into a normal GPU and they'll fit into, a phone by the end of the year, right? And then on the other end of the scale, you have these like, okay, we don't even support them, but, you have like GPT-4 with like 500 gig model, 600 gig. So that's, you're going to see the space sort of go in two ways, and then you have like different products.
When I train some LoRa's for like the models, even though like I was trying to train on a MacBook, and I was trying to train on like a 3090 from like really, really old 3090, and it's still faster to train on 3090s than like MacBooks, but inference seems to not be affected by that. So.
Yeah, I think inference is a lot easier. Fine-tuning is really a different monster altogether. And that's what I'll do, a separate slide deck someday to explain. Yeah, it's really fascinating. And I encourage everybody, I think in the open source space, what is awesome is always that you can promote your competitors. And really in the longer term, you're actually colleagues. Download Ollama if you're a developer, download LM Studio if you're a front-end guy. Play around with all of those things, right? It's absolutely fascinating that you can run a model that performs the way Llama 8B does, right? Let me just ask it a question about like, tell me more about HBM memory or something. Tell me more about HBM memory for GPUs, right? These guys will just think on if you're on a flight or anything, these things are a near human full knowledge of the world as a 4.58 gigabyte file that you can carry with you across borders. I think there's something very profound with that has just shifted beneath our feet.
That seems more than human, no?
I know. I watched a baby grow up. I watched this LLM improve. They are very. This one's the Lulu, yeah. All right.
Still, what would you rather have on a flight?
That's a really good one. You got jokes, man. You got jokes. Yeah. All right. Nothing else? All right. How do I disconnect from everything?
Yeah. Actually, on that point, I've been playing around with Cortex.
Okay, I'm so sorry.
You should be. I have a WhatsApp with him, and it's full of
Bugs.
no, just not just bugs. Feedback, pain, cries. No. Wait, let me.
How do I disconnect from all of this? Oh, okay. All right.
Let me just quickly show you. Wait, present, share screen. Entire screen. Share. Okay. So there's documentation. It very much says it's under construction, which doesn't stop me from running it anyway. One thing is like the copy and paste is a bit tough, but I can open a PR to maybe improve that. But so basically, you can start it up here. So I got Cortex Surf running on 127. By default, it runs on localhost, but actually that has some issues with like remote connection from like certain systems. So I run it on 127. And so, funny story, do people know SourceGraph? Have people heard of SourceGraph? Yeah. A few. So it's like kind of the only sort of real GitHub Copilot alternative, I guess. Longest time very sort of enterprise focused. But so it's basically a bunch of AI tooling that lives within like your VS Code or your IDE. And so here actually I have some configuration where you can basically say, okay, I have an open AI compatible using the model here, Gen, HQ, Tiny Llama. I don't need an API key for this. And then my endpoint is just here, the chat completion. And so they have a chat product basically, which is in there. Maybe I open a new chat. And then you can choose your model. So here, that's my Tiny Llama. What should we ask it?
Does it have context to the file or the repo?
It does, yeah. I think so.
Let's describe the repo.
This is Tiny Llama, so it's a really stupid model.
1.1D.
If it works,
okay, so it says I don't have access to your code base. Interesting.
you should ask it, how do we connect to the code base?
Yeah, how do we connect to the code base? But I think what's interesting is like this is running locally on, this is like an old MacBook Air M1. And it's crazy fast. I think
you're using a stupid, I mean, I can't, is it?
Okay.
It's not politically correct to call it stupid.
Don't use any code suggestion.
But anyway, I think, just what goes to say in terms of developer experience, OpenAI compatible. You just plug it in anything that sort of speaks.
So actually, yesterday a model was released called CodeStroll from Mistral. It's really good.
CodeStroll?
Yeah, CodeStroll.
So can I pull it into Cortex?
I don't think it's been quantized. Oh, really? Oh, we played with it. Okay. I was traveling yesterday, so I actually
That's
have no
fine.
idea.
There's a couple more hours in tonight, so we'll check back tomorrow morning. No. Anyway, please give a big round of applause to Daniel. Oh, wait. No. Oh, Jesus Christ. What am I doing here? Okay, so I think we'll say goodbye to the folks on the live. Well, actually, we can probably leave the live stream up and running. One thing I'd love to do is just take a quick group photo, if that's okay with everyone. So I'll just take a selfie, I guess. How do you take a selfie? Okay, everyone huddle in. Where's everyone? I need to practice my squat. All right, nice. Well, thanks. Yeah, thank you all for joining. And actually, we have some time. Anyone who wants to share what they're working on? Yeah,
I have a let me talk to share my AI project.
for sure. Yeah.
Can I share the screen to the?
Yeah, so I think if you go Apple AirPlay Central Park, you should be able to kick me out, but let me, I think I can also stop. Do you see Central Park?
Yeah.
Yeah, sweet.
It's asking me to enter the code.
Yeah, so it should pop up.
I don't know the code.
Yeah, the code should. Are you connected to the Wi-Fi?
Yeah.
Okay. So the code should pop up on the screen. Wait. Yeah.
Oh,
okay,
okay.
there it is.
Okay.
The camera is some smart tracking. Unfortunately, it's not so smart.
I think also it had a really bad announcement time. That was a good week.
Okay, cool.
Cool.
Sweet.
Okay. Hello, guys. My name is Yuan Lin, and I'm the founder of Zebra. And I want to share some new AI feature of our product. But at the first, I want to take a quick introduction of Zebra because I think some of you may not hear about this path. So basically, Zebra is a platform as a service from Taiwan, and you can think it like a combination of Brazil and render. So Zebra can help you deploy the services to the cloud with one click, no matter what programming languages or framework you are using. Yeah. And we have some feature like you don't need to write a Docker file for your project. And we have a pay-as-you-go billing model. And you can deploy all the services to one platform, including like Next.js or MongoDB or even a Go or Rust service. Yeah, and we are based on so many different cloud providers like AWS or GCP or even DigitalOcean in Singapore. If you are working on a limited budget, because DigitalOcean is cheaper than so many cloud providers. Yeah, and the new feature I want to show you is we released yesterday. It's called Zebra AI because I think so many developers is facing a problem when you deploying services to the cloud that when you deploy your code to the cloud, you may think your deployment is failed, but you don't know why the reason my code is failed. So next step, you need to dive into the build log to see what is the problem, like the video. The status of this deployment is failed. And next up, you need to scroll so many long logs to find the reason. But actually, in Zebra, you can click Ask AI. And we have a AI model to help you analyze your code and the build log or even some services in this project, like maybe connection status or connection issues. And it can even give you some recommend actions like, oh, your project cannot build because there is some connection issue between your services and the MongoDB. So the recommended actions is restart your MongoDB, or even the AI can create a pull request to your service. Yeah, that's the new feature we released yesterday. And you can now join the wait list of our Zebra AI because we are still under development of this new feature. Yeah. Thank you, guys.
Thanks. So how long have you guys been
working on Zebra?
Yeah.
Like a half year.
Half a year?
Yeah.
Oh, nice.
We have a 4 people small team, and we are full-time working on this platform.
Sweet.
Yeah.
So Taiwan-born,
fully remote.
fully
And
remote.
we have a half member from Taiwan and half member from Hangzhou, China. Yeah.
All right, and just multi-cloud, or some. So you do some different cloud providers, right?
Yeah. And we are still trying some new and more cheaper provider like Linode or Volter or even Fly.io.
Gotcha. Yeah, there's
yeah.
one question there.
You said it's a mix of Vercel and something else?
Render.com.
What's render.com?
It's just like another container as a service. Yeah. Maybe you guys hear about Railway?
Yeah.
Yeah, something like that. Render.
And so what's wrong with Vercel or Render?
Vercel can only host serverless service, and Render can only host containerized service. But what if I have a project which front-end use Next.js, which is serverless, but my backend use Rust? Rust cannot be serverless deployment. Yeah, or even I need a database, which is cannot serverless deployment. And there's some template in our landing page. As you can see, you can search Supabase in our template. So if you think,
wait.
Yeah.
But you're deploying it on your infra, right?
You can choose the region where you want to deploy. So if we are from Taiwan, you can select our GCP Taiwan region. So the latency from here will very low.
Yeah. Nice.
Yeah.
Can you do multi-region deployments?
Currently, it's not enabled by default, but we are trying to find a good way. Because if you are deploying some stateful service like MySQL or MongoDB, if we deploy your database into multiple regions, there will be some consistency problem. Yeah, so we are trying to find a way to achieve this. Yeah.
So you have I think Huawei Cloud, right?
Yeah, we have a Huawei Cloud in China region.
Because I used before, like I AWS, right? In
Yeah.
China. Do you ever have problems getting traffic outside of China into like Singapore or whatever?
Yeah, there will be so many problems if you want to send requests from outside of China into the.
No, the other way.
Either way, it depends on which domain you want to request. For example, GitHub or Google is not accessible. But if you have some proxy service which is provided by our platform, then it will not be a problem.
Okay.
Yeah.
Cool.
Yep.
Is there a way to easily migrate from Vercel to yours?
It's one click. It's only one click. Yeah. Because we have a open source project.
How many clicks from Supabase to you?
So we have
One click.
no, maybe yeah.
3 click. PT
So-
dump and a click.
So we have a open source project called ZebraPack. It's like a tool to analyze your code, and with this tool, we can know what programming languages or what framework you are using. So we can, based on the analyzed result, to generate a Docker file or some serverless static files or serverless functions. So we can use this tool to help you very easily deploy your services from your local. Yeah.
Nice. Sweet.
Oh,
I think, yeah. With that, thank you.
Sorry, just one more thing. As you can see on my laptop, there is some sticker. So if you are going to deploy something to the Zebra, you can find me and get some stickers.
All
Yeah.
right. Wow, that reminds me, I forgot all my stickers.
Okay, thank you.
All right, thanks everyone. And with that, we'll stop the live stream. You're very welcome to hang around we have the room until 8:30. So feel free to hang around.